Now, let's go back now to the ease of ionization record. That's what we're talking about. Looking at every single thing that you have here, Morgan, which one do you think would form an ion easily? Which one of these atoms you think would form an ion easily?
Sir, beryllium.
Why? Why you say beryllium? Just random guess.
Uh, Give me a second, sir. Sir, beryllium ion, sir, and itself.
No man, beryllium by itself is an atom, you know. Here, so it's an atom. When this a structure here is an atom, right here. Or you don't know. You think you can get a guess, accurate guess, or you don't know?
Sir, you have, sir, wait for it. You have less energy, sir.
To an extent, you're onto something. You're onto something.
Sir, no, sir.
So let's do it together now, right? So when we talk about ease of ionization, is the ability for the atom to form an ion easily, right?
Yes,
And
sir.
remember, all of these are deemed what we deemed as metals, right? Because they are in group 2, right? Remember, we talk about metals and non-metals. We find metals on the left side of the periodic table, we find non-metals on the right side, right? And we would have mentioned in terms of the groups what's the name of the groups, right? We talk about the halogens, the alkali metals, alkali and earth metals, stuff like that. So for those who don't know, you can go back and watch the videos on YouTube. So all of these are deemed what we call metals, right? And what do we say about metals again? They would gain or they would lose electrons.
Sir?
Metals would gain or they would lose electrons.
Uh, they lose, they lose electrons, sir.
Would lose electrons. Good. So the idea is that which one of these would basically lose electron easily to become an ion. Alright, and we're looking on the trend. Does it increase or does it decrease going down the group? So explain now. So the idea is that what you're seeing here, this shell, right? They would get a pull, right? The nucleus right here. Remember that this is the nucleus of the electrons, remember?
Yes, sir.
Good. And there is always a pull on the shell from the nucleus right here. So the nucleus right here, there's always some form of force between the nucleus, right? The energy level between the nucleus and the shell, right? So the nucleus always have some form of energy. So the idea is that, right, the closer there is, the closer the shells are to the nucleus, the greater the pull on the shell by the nucleus. So if it is that you continuously have more than one shells being added to the structure, when you go down the group, right, there will be less pull from the nucleus on the last shell if there is continuous shells being added. Because guess what? Each shell here, so you have shell 1 right here, you have shell 2 here, you have shell 3, and then you have shell 4. So as you move away from the nucleus, right, each shell use up some amount of energy from the nucleus. So shell 1 use up some amount of energy, shell 2, shell 3, and shell 4. So shell 4 will basically get the least amount of energy or least amount of pull from the nucleus. So the electrons on the last shell, they would get the least amount of energy from the nucleus. So it's easy for something to just come, right, and react with these elements. So react with the electrons and the large shell. So it's easy for the large electrons to be lost because there's a lesser pull from the nucleus. You get that?
Yes, sir.
Right? Some call it the shielding effect, some along the lines. So some persons call it the shielding effect, right? Stuff like that. Remember that there is also a charge as it relates to the protons. So protons are positively charged, electrons are negatively charged. So there will always be some form of attraction between both of them. Good. So if it is that these shells, right, as you go down the group, each an individual shell is added to the structure, right? As you go down the group, the ease of ionization would increase because there is one extra shell being added to the structure as you go down the group. So ease of ionization, that would increase down the group. So it increases down the group. You get what I'm saying?
Yes, sir.
So if the closer the electrons are to the nucleus, the harder it is for the electrons to be lost. So that's how you explain as it relates to ease of ionization. So if the electrons are closer to the nucleus here, it's harder for them to form ions. But the more the electrons, the further the electrons are from the nucleus, right, the lesser the pull on the electrons by the nucleus, by the overall charge on the nucleus. So as I said before, it's easy for the electrons to be lost. So the reactivity will also increase down the group. So ease of ionization increases down the group, reactivity increases down the group as well. Reason being because there is an extra electron shell being added to the structure. And the further the shells are from the nucleus, right, the lesser the pull on the electrons. So in 1 and 2, quick, them electrons here just react. Get that?
Yes, sir.
As I mentioned before, the reason being because there is, as it relates to the outer shell receives the least amount of energy or pull from the nucleus. And that therefore means it's easier for the electrons to be lost. And it's easier for them to form ions. Right? So ease of ionization would therefore increase down the group. The ability for them to form ions increases down the group due to that extra shell being added to the structure. Comprende?
Yes, sir.
For those who are watching this video, again, don't forget to like, share, and subscribe, and can also book a private tutor. Also, if you want free study guides, customized worksheet, you can also reach out to us.